846 words within target range. Here's the script. In 1896, a Swedish physiologist named Torsten Thunberg wrapped his fingers around a coil of interlaced metal bars, one warm, one cool, neither hot enough to injure a human being, and felt his skin begin to burn. Not warm, not tingling. Burning the way a hand burns on a stove. How does a brain generate real, reportable pain from two temperatures that are on their own harmless? More than a century later, neuroscientists have located the exact structure responsible, down to a few cubic centimeters of folded tissue behind the temple. They still cannot explain how it does this. Thunberg ran the experiment on himself, alone, in a lab in Lund. He built the coil by hand, alternating channels of warm water and cool water through thin metal tubing, close enough together that a fingertip touching the grid would cross both temperatures at once. He recorded his own reaction in his notebook almost clinically and moved on. It would take nearly 100 years and the arrival of functional MRI before anyone could show, in real time, which part of the brain lit up when a person touched that grid. That part is the anterior insula, buried in the fold where the frontal and temporal lobes meet, and it does not just register the illusion, it appears to build it. Replications through the 1990s and 2000s confirmed the effect was near universal. Reproducible across cultures, ages, and pain thresholds, the thermal grid illusion became a standard lab tool almost overnight. Nearly everyone who touches the interlaced bars reports true burning pain, sometimes bad enough to flinch away. Skin conductance sensors, the same tech used in lie detectors, spike in response, confirming the body treats it as a real threat. Brain scans taken mid-touch show the anterior insula firing at levels nearly identical to actual tissue injury. No burn, no damage. The alarm goes off anyway, and for decades that was chalked up to simple biology. The obvious theory was mechanical, almost boring. Cold sensing and warmth sensing nerve fibers, researchers proposed, simply cross wires somewhere in the spinal cord before the signal reaches the brain. A wiring glitch downstream, nothing more. Under that theory, the insula was just a passive receiver, lighting up because it was handed a false alarm, the way a smoke detector screams at burnt toast. Tidy, mechanical, and for years it held. Then, in 2007, a neuroscientist named Nasir Naqvi published something that broke the theory apart. He was studying stroke patients with damage to the exact same region, the anterior insula, and noticed something none of them had been asked about. Longtime smokers, some 2 packs a day for decades, had simply stopped. Not tapered, not struggled. One woman described putting down her final cigarette the way you'd set down a glass of water, no craving, no withdrawal, no internal fight. If the insula were only a relay station for crossed pain signals, it had no business controlling nicotine addiction at all. 2 entirely different systems, heat and craving, were routing through the same few millimeters of cortex, and losing that tissue erased both. That is the detail that still resists explanation. A neuroscientist named Bud Craig proposed that the anterior insula is where raw signals from inside the body, heartbeat, gut tension, temperature, the ache of wanting a cigarette, get assembled into a single felt experience. Not a relay, a construction site for the feeling of being a body at all. And here is the part that makes it strange rather than merely elegant. Patients with insula damage can lose the conscious feeling entirely while their body keeps reacting underneath it. Run Thunberg's original grill on a patient like that today, and their skin conductance still spikes. The body still sounds the alarm. But the patient calmly reports feeling nothing at all. The data survives, the feeling doesn't. Researchers have tried to close the case with a handful of competing models, the insula as a hub in a broader salience network, the insula as a predictive engine constantly forecasting the body's next state, the insula as Craig's singular seat of interoceptive awareness. Each explains a slice of the pattern and fails on the same detail, lesion location. 2 patients with nearly identical damage to the region produce wildly different outcomes. One stops craving cigarettes overnight. Another doesn't change at all. One loses the burning grid illusion completely. Another still flinches. No existing model predicts in advance which patient will lose which piece of themselves. So the same few millimeters of cortex sit at the crossing point of pain, craving, disgust, and the raw sense of having a body. And nobody can yet say how it converts a harmless coil of warm and cool metal into real, felt agony, or why removing it can silence a 20-year addiction in a single afternoon, but only sometimes and never predictably. Before any surgery near that region, the honest answer to what a patient stands to lose is still, nobody knows until it happens.